kinematics and solving kinematics problems. To start with, let us define kinematics. Kinematics is a branch of mechanics which deals with equations that describes the motion of an object without external forces. Now we need to familiarize ourselves with these equations. In the first equation, the distance d is equal to the initial velocity v sub I multiplied by time t plus 1/2 of acceleration a multiplied by the square of time t. In the second equation, the square of final velocity is equal to the square of initial velocity plus 2 multiplied by the acceleration times the distance. In the third equation, the final velocity is equal to the initial velocity plus the acceleration times the time. In the fourth equation, the distance is equal to the average velocity, which is the initial velocity, plus the final velocity divided by 2 multiplied by time. So, let us try these equations by solving problems. First, we have a problem concerning horizontal motion. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Now determine the acceleration of the car. Now let us answer it. We are given the initial velocity, which is 0 meters per second because it starts from rest. Next, the time, which is equal to 5.21 seconds, and distance, which is equal to 110 meters. We are asked for the acceleration of the car. So we need to find a formula that has initial velocity, distance, time, and acceleration. The formula that suits for this problem is equation 1. Now we can input the known values and compute for the acceleration. And now we have the acceleration. The acceleration would be equal to 8.10 meters per second squared. Now let's go to the second problem. The second problem will be about vertical motion. Cardo is riding the giant drop at Great America. If Cardo free falls for 2.60 seconds, what will be his final velocity and how far will he fall? We are given the initial velocity, which is 0 meters per second because Cardo experienced free fall motion. Next, the time taken is equal to 2.60 seconds and the acceleration, which is due to gravity, is 9.8 meters per second squared. Lastly, we are asked for his final velocity and the distance of his fall. First, we need to solve for the final velocity. We need to have a formula which has initial velocity, acceleration, and time, and final velocity. We can say that equation 3 suits our needs for us to solve the final velocity. We then input the known values and solve for the final velocity. So the final velocity is equal to 25.48 meters per second. Next, we need to solve for the distance of his fall. Since we have now the final velocity, we can use the equation 4. We then input the known values and solve for the distance. So the distance of Cardo's fall is 33.12 meters. Even if we use equation 3, we will arrive at the same answer. Now let's try it. We input initial velocity and final velocity, acceleration, and solving for the distance. So it is the same with the value we get if we use equation 4, which is 33.12 meters.
Instantaneous velocity. The average velocity does not describe the motion of the particular instant of time during which time interval the average velocity is calculated. Hence, to know how fast the particle moves at a particular instant of time, we define instantaneous velocity. The velocity of a particle at a particular instant of time, not during a finite time interval, is known as instantaneous velocity. The instantaneous velocity, Vx, equals the limiting value of the average velocity, delta x by delta t, as delta t approaches 0. Vx equals to limit delta t tends to 0, delta x by delta t. This limit is called the derivatives of x with respect to t, written as dx by dt. Vx equals to limit delta t tends to 0. Delta x by delta t equals to dx by dt. The instantaneous velocity is a rate of change of position with time. In figure, as the time interval delta t gradually becomes smaller and smaller, the point P2 approaches P1 and the line joining P1 to P2 gets steeper and steeper. This steepness cannot be more than that of the tangent to the curve at time t1, that is, at P1. The slope of this tangent line at P1 is the instantaneous velocity at the time t1. This slope may be positive, x increasing, or negative, x decreasing. Hence, the instantaneous velocity may be positive or negative in straight line motion. The magnitude of the instantaneous velocity is called the instantaneous speed. In uniform motion, the instantaneous velocity of a body is equal to the average velocity.
What is relative motion? The word relative is a general term which can be applied to any physical, non-physical, scalar or vector quantity. All comparisons between any two quantities are relative in nature. For example, let's say Ram's height is 5 feet and 6 inches, while his wife's height is 5 feet and 4 inches. If I ask you, how tall is Ram relative to his wife? Your answer will be 2 inches. How did you find it? You simply subtracted height of Ram's wife from Ram's height. This simple concept can be applied everywhere, whether you want to find relative velocity, relative acceleration, or anything relative to that matter. Using the same logic, the relative velocity of A with respect to B is written as VAB, and it is equal to velocity of A minus velocity of B. Similarly, relative acceleration of A with respect to B is equal to acceleration of A minus acceleration of B. We can also write VAB equal to minus VBA and AAB equal to minus ABA. Let's solve an example to understand this concept better. Question: Chintu is moving due east with a velocity of 1 meter per second and Mintu is moving due west with a velocity of 2 meter per second. What is the velocity of Chintu with respect to Mintu? Solution: this is a one-dimensional motion problem. We are given that the velocity of Chintu is equal to 1 meter per second in east direction, and velocity of Mintu is equal to 2 meter per second in west direction. Before solving the problem further, let's try to understand another important term, frame of reference. Frame for reference is almost like I am carrying a picture frame around with me and trying to see the entire world through this picture frame. Or in other words, I keep this frame as a reference to see things from my point of view. Now, if I call one of the edges of the frame as y-axis and the other edge as x-axis, the corner where both these edges meet becomes the origin. This is my two-dimensional frame of reference. If nothing else is mentioned, then this frame is assumed to be attached to the earth. In the question, our frame of reference is Mintu. We need to find velocity of Chintu with respect to Mintu, which means that we need to know velocity of Chintu from Mintu's point of view. As discussed earlier, to find velocity of Chintu with respect to Mintu, we must subtract the velocity of Chintu from the velocity of Mintu. Mathematically, we can write VCM equal to VC minus VM. Now putting the value of Vc and Vm in this equation, we get velocity of Chintu with respect to Mintu, 3 meter per second. This is the desired answer.